Hello, today we are going to see the video of some problems from the topic combinations of mathematics for grade 12. Uh, and this video is designed to help the students for revisions of their course during this lockdown period. Okay, let us start the videos. Now, combinations. Combination is just a selection, the process of selecting the objects without regard of order. In previous videos, we have discussed about the permutations, and permutation is a arrangement of the objects in a definite order or a specific order. But combination is not like that. The order is not specific in combinations. Okay. Combination is process of selecting object without any specific order. So we have some problems, and before solving that problem, I would like to write the formula of combinations. Formula. The number of ways of selecting n objects taken are at a time is given by CNR equal to n factorial divided by n minus r factorial times r factorial. This is the formula that we have derived in class. I will not derive it here. So also I assume that you know the factorial notations. So the number of ways of selecting n objects taken r at a time is given by CNR, and this CNR is sometimes written as NCR. Okay, CNR or NCR, they are the same. The combination of R object taken from N objects. Okay, this is the formula that we used here. We also use a principle of counting here also. If there is more than one task involved in the solutions of the problem. Okay, now I start the solutions. Okay, look at the first problem. In how many ways can a student choose 5 courses out of 9 courses if 2 courses are compulsory for every student? So, in the solution of 1, here, the total course, total course is total number of course. Total number of course is 9, and student has to choose 5 courses. Okay, number of courses is 9, and a student has to choose 5 courses. Look at here. And provided that 2 courses are compulsory, that means out of 5, out of which 2 courses are compulsory. The 2 courses are compulsory. This is just information taken from the question. So what we see here, how we combine the combinations of selecting the courses. 2. So now we can write that out of total courses is 9, 2 courses are already selected. That means 2 is compulsory. That means n equal to 9 minus 2, that becomes 7. And the object to be taken at a time, that is r, is 5 minus 2, that is 3. So then CNR equal to, we can write that n factorial by n minus r factorial times r factorial. Okay, so or Cn is 7, 3 is equal to 7 factorial divided by 7 minus 3 factorial times r factorial, that is 3 factorial, and this equals 7 into 6 into 5 into 4 factorial. We stop here because 7 minus 3 is 4. Okay, divided by 7 minus 3 is 4 factorial and times 3 into 2 into 1, and this equals 4 and 4 factorials, they cancel out one times. 3 1 is 3, 3 2 is 6, and 3 2 is 6, and 6 cancels. So the product is 7 times 5, that is 35 ways. So hence the students can select or choose the courses in 35 ways. Okay, this completes the solution of first question. Okay, now we solve the another question. Look at the solutions. So you remember that 5 courses, out of which 2 are compulsory or chosen, courses are compulsory. So we subtract that 2 from each, okay, from total, and the course to be selected. Okay. Okay, now we solve another question. Question number 2. That is question number 2. Let us look at the question number. How many ways can a cricket 11, that is cricket team of 11, be selected from 15 players, in which 5 players can bowl, and each cricket team must include 2 bowlers? So generally you know that there are 11 players in the cricket teams, and the players are, various type of players are there. Their role are different. Some of them are wicket keepers, some of them are batsmen, some of them are bowlers. So in these questions the team must include 2 bowlers. 2 bowlers must include. So these 2 bowlers can be selected from the set of bowlers. This is the set of bowlers. 5 players can bowl, means bowlers, number of bowlers is 5, and 2 bowlers must include in that team. So 2 bowlers is selected from 5 bowlers, and remaining players, now out of 11 players, 2 players are bowlers. That means we have still to select the 9 players. Okay, so now starting the solutions, how we combine this selection of team. So here the number of players, total number of players, total number of players, there as no, don't write in, is 50, and number of players who can bowl is 5. So number of other players is equal to 15 minus 5, that is 10. Okay, so we have two set of players. One is bowlers, another is other players. Okay, now we have to select. Since 5 players can bowl, out of which 2 must be included, and the team of the player is 11, so number of players in a team. Players in cricket team is 11. So we have to select 11 players from this 5 and 10 players. Okay. So now the combinations. Now first we find the selection of bowlers. Okay. Now combination of bowlers. You can write also the combination of bowlers is equal to, since 2 players must include, you write here, in which 2 bowlers must include. Okay, so the combination of bowler is bowler is C. How many bowlers are there? 5. And how many bowlers should be selected for the team? It is 2. So this equals, you can write this much only for here. And now another is combination of other players. So look at here, it is a combination of other players, remaining players. Total is 10. We have to select it from 10, and out of 11 players, 2 is already selected as a bowlers. So we left 11 minus 2 is 9. Okay, since 11 minus 2 equals 9 players. This is the other players. Okay, so this is the combination of the other players. This is the combination of bowlers, or in other words, number of selection of bowlers, number of selection of other players. So by principle of counting, then now the number of, okay, you can write required number of ways of selecting the cricket team. Okay, cricket team is equal to C52 times C10 comma 9. Okay, and you can calculate it yourself, and it is left as an exercise for you to calculate. Okay, 5 minus 2 factorial times 2 factorials into 10 factorial by 10 minus 9 factorial times 9 factorial, and this gives 100 ways. This is the solution of second question. Okay, look at here, 5 bowlers, other players is 10, because their total 15 minus number of bowlers 10 becomes, and number of players in cricket team is 11, in which 2 bowlers must include. So first we combine or we find the number of ways of selecting the bowlers, that is 5 2, because the number of bowlers is 5. We have to select these 2 players, 2 bowlers from 5. So 5 C5, 2, and other players. 2 is already chosen as the bowlers, and then combination of other players is 10, because the other players total 10. We have to select 9 remaining players. Okay, that is 11, because 11 minus 2 is equal to 9. See, 10 9. And this is the solution of question number 2. Now we have a solution for question number 3. Okay, now we solve the question number 3. Let us have a look at these questions. A committee of 5 is to form out of 6 gents and 4 ladies. In how many ways can this be done when at least 2 ladies are included? Okay, I have pointed here at least 2. At least. At least 2. First of all, let us discuss about the at least. Meaning of at least 2. This at least 2 means 2 or more. Okay, it means 2 or more. So same, if it is at most 2, it means then, what does it mean? It means 2 or less. Okay, so remember that this point, these 2 points. At least 2 means 2 or more. At most 2 means 2 or less. So we have a various case. At least 2 means it may contain 2, 3, 4, and so on. And the last number depends on the total number of the given objects. Okay, at most 2 means 2 or less means it means 2, 1, 0. Because the number of person cannot be negative, we do not go beyond 0. Okay, so 2, 1, 0, it ends up to 0. And also this also depends on the number of objects given in the questions. Okay, this point should be noted when we have given the problem that consists of at least 2, at most 2, and so on. Okay, now we start the solutions of question number 3. So here the number of genes, here number of genes, that is 6, and number of ladies, that is 4, and we have to select a committee of 5. Okay, number of members in a committee, that is 5. We have to select the 5 committee, in which we have conditions in which at least 2 ladies are included, in which at least 2 ladies are included, in which at least 2 ladies are included. This is given in the questions. Okay, now to solve this problem we make a table. Okay, so we write table of combinations. Okay, so we have a ladies and gents, and because the ladies are at least 2 ladies are included, so you write ladies and then column of gents, column of ladies, and the combination. number of committee. Okay, so look at it now. So how many possible cases? At least two ladies. So first of all, fixed the number of ladies. At least two ladies. That is, it means two or more. Okay, at least two ladies means two or more ladies. So we have total number of four ladies. So the ladies may be 2, 3, 4. Okay, because there are only 4 ladies available for the selections. So we must have 2 ladies, 3 ladies or 4 ladies. In case 1. Okay, now we make a committee. When there in a committee of 5 members, if there are 3 ladies, then there must be 3 gents. Okay, and if there are 3 ladies, then gents must be 2, because the total member of committee is 5. So 2 plus 3, 5. 3 plus 2, 5. And if there are 4 ladies members, then there must be 1 gents member. That is 4 plus 1, 5. So now we make a combinations. This is the number of committee, that is combinations. You know, it is a combination. So how can we combination? These 2 ladies can be selected from 4 ladies. So C4, 2 times 3 gents are selected from the 6 gentlemen. So C6, 3. Okay. Similarly, here C4, 3 times C6, 2 times, and C4, 4 times, C6, 1 times. And this is the number of committees or combinations. Okay, under these given conditions. Hence, the required number of committee. Okay, and the required number of committee equal to the sum of all these row. Okay, C4, 2 into C6, 3 plus C4, 3 into C6, 2 plus C4, 4. Okay, C4, 4 into C6, 1. So use the formula of combinations and simplify it. Okay, you will get the values 186, and this calculation is left as an exercise for you. You can easily calculate it. You try your best, and this is the solution of question number 3. So now we have one more change in that question number 3. How will it change? Let us suppose the question number 3. Now we write that 3A, another questions. Okay, let us make it 3A, and in place of at least, let us make it at most. At most 2 ladies. Okay, at most 2 ladies. So what we see then, now the question is, a committee of 5 is to be formed out of 6 gents and 4 ladies. In how many ways can this be done when at most 2 ladies are included? Okay, so the same number of gents, same number of ladies, number of members in a committee is 5, out of which, at most 2 ladies are included. Okay, at most 2 ladies are included. Then that is 2 or less. Okay, then number of table of combination we make. Now we start from 2. 2 or less, that means it may be 2 members of ladies or 1 members of ladies or 0 member of ladies. Let us see what we make here. Okay, so if there are, let us clear it. Okay, so look at here. So if the committee consists of 2 ladies, then there must be 3 gents. So the combination of this ladies and gents is C 4 2 times C 6 3. Okay, then when 1 ladies, then there must be 4 gents, and then we write C 4 1 times C, that is 6 4. Okay, so look at it now. If there is no ladies, then all the members is gents. Okay, all 5 members are gents. So we have 6 gents. Okay, so we write C 40 into C 6 5. Okay, and this combinations gives the required number of combinations, or so the required number of committee is equal to, right, C 42 into C 63 plus C 41 into C 64 plus C 40 into C 65, and calculation is left hand exercise, and the result is again 186. Okay, do it yourself, find it. Okay, when we change it like this at most, okay, then we have another problem. Okay, let us have another. It is in case of at most. Then when at most, you write at most, not ladies, but it is gents, and say it is B. Okay, 3B. Another one questions we have added. At that case, the same number of gents and same number of ladies, committee says at most 2 gents. Okay, that means 2 or less gents. So we start here from gents and ladies. Okay, right? First gents, then ladies. If we write like this, then it is easy to combine the ladies and gents. Look at it now. Gents 2, ladies is 3. Gents 1, ladies 4. If there is no gents, then all members is ladies. But there are only 4 ladies. So this is impossible. This combination is impossible. This combination is impossible. So we have only first 2 combinations. Okay, that means C 6 2 times C 4 3, and C 6 1 times C 4 4. Okay, and this is the combination. This is impossible because 0 gender means almost be ladies, but there are only 4 ladies, so this is not possible. So we have only this much equal to C 6 2 into C 4 3 plus C 6 1 times C 4 4. Okay, say it is 4 4. Okay, and on calculations you will get the value is 65. Okay, you do yourself calculations, and this is my calculation. You can do yourself and test the result. Okay, this was for this video. I will solve the remaining 4 and 5 video solutions in next videos because it's taking long time. Around more than 30 minutes have been gone. Okay, thank you for watching this video.